This is passage 1. It's a conflicts passage in test 61C. So we identify this as a conflicts passage because we can see that there's different approaches. Student 1, Student 2, Student 3, and Student 4. These will either say student or scientist or method. It won't say study or experiment. Those are research, but that's how you identify conflicts passages. The DRC approach, remember, conflicts you carefully read, or at least more carefully than the others. There's only one conflicts passage per test. It presents a conflicts and different approaches. You have to identify the conflict, what's the disagreement about, then annotate the differences, understand what's going on. Step 1 is to identify the conflict. It's usually the last paragraph of the intro. So the introduction before you get to the disagreements is here. So skim the introduction part, but then focus quite a bit on the last paragraph. So this is the conflict. 4 students studied the way in which 6 genes on a plasmid were donated. The students determined the entire plasmid is transferred in 90 minutes, and the rate of transfer is constant. They also determined the genes are evenly spaced, so 1 gene is transferred every 15 minutes. They disagreed, however, about the order in which the genes are replicated and thus transferred. So that's the conflict. They agree about timing, but they disagree about order. And that's very important. So now you're just going to say, well, what does each student say about the order? You know what you're looking for now. Step 2 is to identify the differences. Sometimes it helps to draw pictures. You might annotate. So the differences are found where it says student 1, student 2, student 3, student 4. Remember, this could say scientist 1, scientist 2, or method 1, method 2. You usually won't have more than 4 different conflicting viewpoints. So they agree about timing, they disagree about order, so you want to know what are their differences. Look at student 1 first. Replication begins between F and X. So I'm going to put a line just so that's where it begins. X is first, so X is first, and F is last. So I'm just going to draw arrows to say first and last. So that's my picture to understand the order of the gene replication. Student 2, replication begins between F and X again. Same as student 1. It's nice to know when they're same. However, the direction varies. If X is first, X is last. If X is first, F is last. So it could go either direction. So that's the difference between 1 and 2. It could go either direction. Student 3, replication can begin between any 2 genes. Just draw lines between any 2. Proceeds around in a clockwise direction. So I'm just going to draw arrows all the way around. And then student 4, replication can begin between any 2 genes again. So the same as student 3. So student 1 and 2 are similar, and student 3 and 4 are similar. So lines again. Replication can proceed in either direction. Okay, so student 3 said clockwise, student 4 said either direction. So now we can see them laid out. Student 1 and 2 are very similar, they differ in direction, and student 3 or 4 are similar, they differ in direction. Student 2 and 4 are similar in that they believe it can go either direction, and student 1 and 2 both go clockwise. So on your test, you won't have computer animation. So these are my drawings. I just quickly sketched something out beside each student to help me remember what they proposed. And that's what you got to do. You don't have to remember long term. You just have to remember temporarily what each student believes. Step 3 is to answer the questions. Hopefully you spent enough time understanding the passage that when you get to the questions, the answers are easier to find. Question number 1, based on the information presented, so this is information just in general, we know what the conflict was. If the transfer of the linear copy was interrupted after 50 minutes, how many complete genes would have been transferred? So this is just from the reading. We say the entire transfer took 90 minutes and 1 gene is transferred every 15 minutes. So you could set up a proportion 1 and 15 equals how many over 50, so 3 full genes. Or you just say 15, 1 gene is 15 minutes, so 15, 30, 45, so 3 genes, however you do it, it's 3. That comes from the reading, comes from understanding. Number 2, based on the model presented by student 3, put your finger on student 3. All 6 genes were replicated, and the first gene is gene G. The third would be which one? So they go clockwise, and first is gene G, so that's going to be here. The second is F, the third would be X. All right, just 1, 2, 3. Which students believe that any of the 6 genes can be the first transferred? So if we look at our diagrams that we drew, we can see that student 3 can begin anywhere. That's why we drew those lines all the way around. And student 4 also believes that. So student 3 and 4, C. Suppose the model presented by student 1 is correct. So let's look at student 1. And the transfer of genes is interrupted after 45 minutes. So each gene takes 15 minutes. So 3 full genes will be transferred in 45 minutes. 15, 30, 45. Which of the following would not have been transferred? So we would have gene X, R, and S. So X, R, and S would have been. So G would not have been transferred. So your answer is F. Suppose that student 2's model is correct. So find student 2, make sure you're looking at the correct one, put your finger on it. The transfer of genes between 2 bacteria was interrupted after 30 minutes. So again, 15 minutes per gene. They don't disagree about timing. So 2 genes will be transferred in 30 minutes, which would not be. So this one, they could go either direction according to student 2. So X, R, G, F. So R, G, and X are transferred. A would definitely not be, so the answer is A. Suppose all 6 genes are transferred from a donor bacterium. So all 6 genes, so let's look at all the recipients. Which of the students argue that gene A could be the last? This is very similar to question 3. So the question 3, I think, asks which one could be first. This says which one could be last. It's really the same idea. So it could be either 3 or 4 only. So J. If you got 3 right, you probably got 6 right. If you got 3 wrong, you probably got 6 wrong. Or maybe you got 6 right and realized, oh wait, I misread question 3. Let me go back. So, all right, so we're using student 1. So put your finger on student 1. The transfer between 2 genes was interrupted. The last gene transferred was A. Okay. No incomplete copies were transferred. Student A would say the transfer was most likely interrupted how many minutes after the transfer began. So we know that it takes 15 minutes for one gene. So 1, 2, 3, 4. That means 4 genes in 60 minutes. 15, 30, 45, 60. So it's interrupted after 60 minutes. So D. Just to recap our answers, number 1 is B, 2 is J, 3 C, 4 F, 5 A, 6 J, 7 D.